In this video, I'm going to show you how to solve polynomial inequalities such as these. You can see all of the steps laid out for you right here, but I'm not going to read those to you. I'm just going to go through the steps one by one. The first thing you need to do is solve the related equation. Okay, so actually, first I'm going to get 0 on one side. So obviously if I were to add 3 to both sides, I would have x squared minus 6x minus 27 is greater than 0. Okay? Now, the related equation is x squared minus 6x minus 27 is equal to 0. We're going to solve this equation. That's going to give us the critical values that we need, and then we'll go from there. My instinct is to try to factor this. Okay, if it's not factorable, then I'll have to do the quadratic formula or complete the square. Is this factorable though?
Yes.
Okay, 27, how does that factor down? Yeah, 3 and 9. Okay, I need a negative 6 in the middle, so negative 9 and positive 3. So of course, we solve this by setting these factors equal to 0. So we get x is equal to 9 and x is equal to negative 3. Now, these are called the critical values. What we do with these critical values is we graph them on a number line. Okay, so here's the number line. So put these in order. So here's negative 3, and here's 9. All right, that's all we need in terms of a number line. Now, at these critical values, did the function will these two values be included in my solution? All right, do I want the function to equal 0 or to be greater than 0? Simply greater. There's no equal to sign, so these will be like open circles. Okay, these points themselves are not to be included in the solution set. Okay, and the rest is all about test values. We need to figure out, thank you, what's the value of the function in each one of these zones. So for example, to the left of negative 3, I might check and see what's the value of the function at negative 4. What would be a really good value to use in between negative 3 and 9? 0. You definitely want to use 0 when you can. So I want to figure out what's f at 0. And then I guess I'll just do f at 10. Okay? All right, I think I'll use, since I don't have a calculator that I'm allowed to use, I think I'm going to use the factored form to help me out. So, for example, looking at this x minus 9 and x plus 3. Okay? So this would be, if I let x be negative 4, this would be negative 4 minus 9 and negative 4 plus 3. And the question is this greater than 0 or not? Well, this would be a negative number, and this would be a negative number. Okay? But of course, what do you get when you do a negative times a negative? That's going to be a positive. Okay? So this is a true statement. All right? This is going to be, it's positive, it's going to be greater than 0. So that means this is like a yes. Okay, this is true. So if this is a solution, that means everything in this zone is a solution. So I'm just going to draw this arrow indicating that I have a bunch of solutions right here. Okay, so I checked negative 4 and got a yes. Let's see, now I'm going to check 0. All right. For 0, it's probably, well, okay. Doing the same thing, if I had 0 minus 9 and 0 plus 3, okay, and I want to see if that is greater than 0, well, obviously I've got negative 9 and positive 3. That's negative 27. Is that greater than 0? No, that's a negative number. So that fails. That means there will be no solutions in that zone. So I'm just going to leave that blank. I'm going to leave that empty. Okay. And finally, I'm going to test 10. So if I do 10 minus 9 and 10 plus 3, and I'm trying to see, is that greater than 0? Well, that's going to be 1 and 13. Okay, so that's 13. So that's definitely greater than 0. So I got another yes. So that means 10 is a solution, which means that everything in this zone is a solution. Okay? So looking at that graph, it should be easy to write the answer in interval notation. Okay? So can you tell me the answer in interval notation, please? Anybody? Parentheses. Okay, do you guys understand why I'm using parentheses and not brackets on those points negative 3 and 9? All right, open circles equal parentheses. All right, any questions on that one? Okay, let's do the same thing again for problem number 2, or whatever number this is. Okay, so first I'm going to get 0 on one side. So I'm going to subtract 2x and I'm going to add 16. So that's going to give me 2x squared minus 12x plus 16 is less than or equal to 0. I might as well divide everything by 2, make my life easier. So this will be x squared minus 6x plus 8 is less than or equal to 0. If I were to factor this down, does this factor? Probably.
Yeah.
Okay, negative 4 and negative 2. All right, so this is what we need to ultimately solve. Now, if I solve the related equation where this equals 0, then of course that's going to give me x is equal to 4 and x is equal to 2. So again, these are my critical values and I will use them to make the number line. Okay, let's see. So I've got 2 and 4. All right. These are going to be closed circles this time because of the or equal to part of it. So closed circles. So I'm going to check f at 0, f at 3, and f at 5, and see what I get for each one of those. So I'm looking at this version of the equation when I do this, by the way. So if f is 0, then that would be 0 minus 4 times 0 minus 2. And I'm asking myself, is that less than or equal to 0? Well, that would be negative 4 times negative 2. That would be positive 8. Okay, is that less than or equal to 0? No. Okay, so I have no solutions in the first area. Okay, let me switch colors. Now I'm doing the 3. So this would be, whoops, I put 0 again. So this would be 3 minus 4 times 3 minus 2. And I'm checking to see if that's less than or equal to 0. Well, this would be negative 1 times positive 1. Okay, which is negative 1. Is that less than or equal to 0?
Yes.
Yes. Okay, that means that 3 is a solution. So that means everything in this zone is a solution. So I'll show that with a little line like that. And finally, I will check the 5. So if I do 5 minus 4, 5 minus 2, and is that less than or equal to 0? Well, this would be 1 times 3. Okay, so obviously 3 is not less than or equal to 0. So I got another no. So I leave that blank. So this graph now shows me the solution set. What would this be in interval notation? Anybody?
2, 4.
All right. 2. Whoa, why did that ink get so thick all of a sudden? Okay, I heard 2 comma 4 with brackets on both sides. Okay, that's it. Any questions on that problem? Okay, again, let's factor this. Does this factor? No. Oh, boo. Okay, well, this does not factor. So since it doesn't factor, what am I going to have to do instead? All right, I would either have to complete the square, which I would love to do if this was an even number. But with that being an odd number, I would rather do what? Quadratic formula. All right, that's what we got to do. Okay, quadratic formula, I see you. So I'm solving the related equation x squared plus 5x plus 8 equals 0 using the quadratic formula. So remember that the quadratic formula goes x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be, let's see, opposite of b, so negative 5 plus or minus the square root. B squared is 25 minus 4. A is 1, so I'm not going to write that down, times 8, all over 2a, which will just be 2. So that's going to give me x is equal to negative 5 plus or minus the square root of, interesting, 25 minus 32. Why did I say interesting just then? Yeah, I'm about to get a negative number, yeah? All right. Negative what? Okay. So this has no solution. Now, that does not mean that the answer to this inequality is no solution. That does not mean that. That just means that there are no zeros. Okay? There are no x-intercepts. So normally we have our number line, and we'll have some critical values up here to put. And then those critical values, we'll test them and see where the solutions are. In this case, we have just only one zone. So it's either going to be infinitely many solutions or no solution. We don't know until we test a value. Guess which value I'm going to pick to test it?
0.
0 would be the quickest, right? We don't even really need to write it down, do we? Because if I look at the original equation, if I put 0 in for x, and those are gone, and I end up with this. 8 is less than 0. Is that a yes or a no? That's a no. Okay? So, because this is a no, that means this was in fact no solution. All right, but please understand, if this had been a yes, it would have been infinitely many solutions. If this had been a yes, right now I'd be writing down the interval negative infinity to positive infinity, if that had been a yes. Okay? All right. Last problem for this video. Does this factor? Oh yeah, okay. So another quadratic formula problem. This can't be factored.
No, you can do completing squares.
Oh yeah, let's complete the square this time. Yay! So I'm solving the related equation x squared plus 2x plus 5 is equal to 0. But this time I'm going to complete the square. I'm going to get that 5 out of there. So that would be x squared plus 2x, leave a space, negative 5. This trinomial, including the missing term here, can be written as a binomial squared. The binomial will be x plus 1. Where'd the 1 come from? Half of the 2. That's where the 1 comes from. If I take that 1 and square it, what do I get? 1 still. That tells me what goes here, plus 1. I got to put it on both sides of the equation to keep the equation balanced. So that gives me equals negative 4. Again, this has no solution. Okay? But that doesn't necessarily mean that the inequality has no solution. That just means there's no critical values. That means I have one big fat zone to check, but I do need to check. I'm going to check f at 0 and see what happens. All right? If this turns out to be false, then I'll have no solution again. If it turns out to be true, it'll be negative infinity to positive infinity. So this time, I put in 0. Okay? So I get 5 is less than or equal to 0. Well, it would have been nice. I need to change this problem. It wouldn't it be better to have like one of each answer? Yeah, like for next year. I got another no solution, which kind of makes me sad because I wanted to see the other outcome. Okay, but instead I just have to say, like, yeah, this was a no. But if it had been a yes, then I would have said negative infinity to positive infinity. But that didn't happen, so I'll just stick with no solution. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.